Assalamualaikum and a very good evening to Madam Faiza and to all my group mates. Today we would like to present about our assignment, Conduction Graphical Analysis on Heat Transfer. Next. Okay, in our slide, there's 5 contents, which is introductions, will represent by Navin. Meanwhile, I will brief about design and analysis, and for discussion, AQILAH will explain it further, and for conclusion, will be conducted by Daniel. So we will go to introduction.
Okay, thank you, Fatin. My name is NAVINDREN. So today I will discuss about the introduction. So the question is, what is the definition of heat sink? A heat sink is a component that helps to transfer heat away from a hot device. It achieves this by increasing the device operating surface area and the amount of low temperature fluid that flows through it. In other words, a heat sink is a device that transfers thermal energy from a hotter device to a cooler fluid medium. Air is the most common fluid, but it can also be water, refrigerants, or oil. You know that we have 3 types of heat transfer, which is the first one is convection, second one is radiation, and the third one is conduction. Transfer heat through these 3 types of heat transfer. Practical heat sinks for electronic equipment must have a temperature greater than the surrounding environment. As another question, highly demanded by other people is, what is the application of heat sink? The application of heat sinks are utilized with high power semiconductor devices like power transistors and optoelectronics such as lasers and light emitting diodes, which is LEDs, where the component's heat dissipation capability is insufficient to keep the temperature under control. That's all from me. I'll pass to the next person to continue.
Thank you, Navin. I will explain further about design and analysis. So overall, we have 2 types of design which label design 1 and design 2. So both of the design have same dimension, same base dimension, is 40 mm times 40 mm. Next. So this is for analysis. We use ambient temperature, which is 28 degrees, and for fins, base size is 40 mm times 40 mm, and for convection coefficient is 5.03, and for average heat flux on cold side, we use 1500. Average temperature on cold side is 76.6, and for average temperature on hot side is 97.2, as stated in the assignment sheets. Next. Okay, based on figure, the highest temperature distribution occurs in the bottom part of the heatsink, and further from the bottom part of the heatsink, the temperature gets lower. Then the heat source spreads slowly to another part of the heatsink. Here, there's a contact between device and heatsink, causing conduction to occur. Conduction occurs when heat is released by the device and another component of electronic to the heatsink. After that, convection occurs when the heat in the heatsink is removed by the converting air inlet. Fluid flow is multi-phase here. Besides, this explains the reason electronic components should be arranged away or shielded from heat sources to prevent overheating and eventually causing damage. Furthermore, the maximum temperature of the heatsink is inversely proportional to the inlet wind. The higher the velocity of the air inlet causes, the lower the maximum temperature of the heatsink. That's all for me. I will pass to AQILAH for discussion and comparison.
Okay, thank you, Fatin. I am AQILAH and I will share more on discussion. Okay, so first of all, our materials that we use for both of our design is copper. Because of what? Because copper offers a lot of excellent aspects such as excellent thermal conductivity, excellent heat absorption, and etc. Its property make it an excellent material for heat transfer, but unfortunately, it is quite expensive compared to other material. Next, the number of fins indicate the surface area exposed. The more surface area exposed, it leads to the more heat removal. Thus, the heat remains in the heat sink will be much lesser. And then, the rate of heat transfer is higher if the if the fin is thinner. And finally, the fin spacing will give the effectiveness in the heat sink. The smaller space between the fins, the greater the effectiveness. Moving on to the next slide, which is the comparison. Okay, as I said before, the material for both design is copper. And then the number of fins and the thickness of the spacing share the same value, but different for each design. Okay, sorry, the number of fins for design 1 is 26. Meanwhile, design 2 is 38. While the thickness of the fin for design 1 is 1.0 cm and design 2 is 0.5 cm. The fin spacing for design 1 is 1.0 and design 2 0.5 cm. The effectiveness for design 1 is lower compared to design 2. Because of what? Because I've mentioned before, since the fin spacing of design 1 is greater than design 2. And finally, the thermal range of design 1 is between 76.5 to 97.3 degrees Celsius. Meanwhile, design 2, which is much lower, which is 40.4 until 40.9 degrees Celsius. So that's all from me. Thank you. Moving on to the next person.
Thank you, AQILAH. I will explain about the conclusion. In conclusion, heatsink design 2 is a lot better than design 1. This is because of the thermal range for design 2 is between 40.4 degrees Celsius to 40.9 degrees Celsius compared to design 1, which is 76.5 degrees Celsius to 97.3 degrees Celsius. The efficient thermal conductivity of copper profile is a decisive factor in maintaining good heat dissipation and an ideal medium for conversion of thermal energy. The fin arrangement for design 2 is much better compared to design 1. In general, the more surface area a heatsink has, the better it works. The fin spacing and the fin thickness for design 2 is better than the design 1 because its small size can make more heatsink be made into one heatsink. That's all from us. Thank you.